Hello, friends, and welcome to the second session of structural equation modeling using Amos. Uh, the session will outline how to use the software, how to create a measurement model or a structural model, and the basics. So, in our previous session, we understood what is structural equation modeling, how is it useful, and we understood what is a construct. So let's recap. Basically, in research or social sciences research, we are mostly interested in the relationship between the dependent and the independent variable. And as we mentioned in our previous class, structural equation modeling is more adept at working with latent variables or constructs. Now, what's a construct or a latent variable? A simple definition would be that a construct is something that is not directly measurable. So basically, your attitude would not have a scale available to measure attitude. It can only be manifested through the items or the indicators. So we come to what are indicators. Indicators are called as items or manifest variables. They are also called as observed variables because we can directly measure them. Now, how do you measure something which is imaginary or something like an attitude? So researchers have come up with certain statements or questions which we measure using a Likert scale. A Likert scale is anchored on a scale of 1 to 5, where a respondent will answer if he very much agrees, he agrees, neither agree or disagree, disagrees, or very much he disagrees with the statement. So that would be a scale which we would convert into a continuous variable. And finally, we have error terms. Error terms are nothing but your measurement errors, or the part of the measurement which cannot be explained, or the unexplained variance. So let's look at this diagram. So as we saw in our previous session, perceived usefulness was a construct developed by Davis in his technology adoption model. What it means, it's perceived usefulness or the utility when you adopt a particular technology. Assuming today cryptocurrency or blockchain is a new technology, and researchers who want to look at how blockchain is being utilized or being adopted would identify certain constructs and measure them. So perceived usefulness would be one of those constructs which measures the utility of using a blockchain. Now, as it is an unobserved variable or a latent variable, there are no ready-made scales to measure that. So we have certain other observed variables or items such as PU1, PU2, PU3, and PU4. So these are statements or questions developed by certain researchers which are reliable and validated in multiple researchers. So coming to our discussion, perceived usefulness would be a construct, whereas the items would be PU1, 2, 3. Similarly, in this research, I have considered three constructs. One is perceived usefulness, the other is perceived ease of use, and the third one is behavioral intention. To give you an understanding, perceived ease of use explains the complexity of the system. How easy is it to use, or is it difficult to use? So if it is easy to use, the technology would be adopted. In case it's difficult, the intention of the consumer would be to not use. And finally, there is behavioral intention. So let me see if I can show you how do I measure these particular items. Okay, this is the appendix I had shared in one of my research papers, where I am measuring perceived usefulness. So if you will see here, there are 4 questions that I will administer to my respondents. PU1, the process of, say, P2P lending. So in this case, I am looking at the adoption of a fintech technology, which is P2P lending. P2P lending is nothing but the lending that happens between a person and a person, intermediated by a platform. So in this case, the question that I asked the respondent is, the process of P2P lending makes my lending and borrowing much faster. So he would answer it very likely, less likely, neither likely nor unlikely. So I would have a question measured with 5-point Likert scale. Similarly, my second question to measure perceived usefulness would be P2P lending services make it easier for carrying out lending and borrowing. So all these 4 questions, if you observe, they seem to be similar in nature. So if you will measure the correlation between each of these would have very high correlations and they converge on the construct called as perceived usefulness. Similarly, I have a second construct which is perceived ease of use, which is nothing but the complexity of the system. So my first question is, learning and operating P2P lending platform would be easy for me. Second question, similarly, I would find it easy to explore and understand the features of P2P lending platform. So similarly, if you are conducting a social sciences research and you have identified certain constructs, you would be able to find the items from any peer-reviewed article. Okay, so we have discussed what are constructs or variables. We have discussed how to measure those constructs, and finally the error terms or the measurement error. So your first generation multivariate analysis tools like regression correlations would ignore the error terms, though they would impact the relationship between the dependent and independent variables. Structural equation modeling, which is the second level multivariate data analysis tools, has the ability to account for error terms. So when I describe the relation between the dependent and independent, they are much more reliable and valid relationship. And finally, this is the research model that we would be looking at. I would be just sharing the Amos graphics here to understand how to use Amos. Okay, so this is the Amos tool. So the version that I am using is the Amos 23, IBM Amos 23 version. Uh, First time when you can come and click on the new button. It opens the canvas for you to use. Now there are certain buttons or graphical buttons given on the left hand side which help you create a path diagram which denotes the relationship between the independent and dependent variable. So I have a rectangular box which depicts an observed variable or the items. The oval or a circular button describes the unobserved variable. In our case, it would be, say, perceived usefulness or perceived ease of use. And I have a composite button which draws a latent variable, including the indicator and the error terms. So let's click on it, and you come to the canvas, and you click once, twice, thrice. So assuming I have 4 indicator items, I want to name this latent variable as perceived usefulness. So I double click on it and I click on the name. So I write perceived usefulness. So I want to create 3 more latent variables. So I follow the same process. Okay, there is another shortcut which you can follow rather than using the draw the latent variable. There is a copy button. So what I do is I select. So there is so this, if you look at my cursor, this is select one object at a time. This is select all objects, and this is deselect. So I click on select all objects, and there is this duplicate objects button. So I come here, I click on it. So I want three particular latent variables. Okay, so this is what I go and unselect all. Now I come to the second latent variable and I want to change the name. So I again click on the label and I can change the name as ease of use. Without closing the window, I come to the third variable and I change the name to behavioral intention. Perfect. Now I want to add, okay, so let me show you some other functionalities. So assuming I want to change the shape or the appearance of the latent variable. So there is something called as rotate the indicators. So I select perceived usefulness and the error terms and I click on rotate. So I can rotate it. In case you don't want to do that, you can also click on rotate indicators and click on preserve symmetries and rotate. So this is the look that you want to give. You want to move certain variables and place them. So you can click on move objects and click on preserve symmetries. And you can move this and place it side by side. Similarly, I want to move behavioral intention. In case I want to take the error terms closer, this is how I move. So please remember, you would have to click on move objects and preserve symmetries simultaneously. Now I want to add my measurement terms. So I click on the data file. I'm searching for the data file. So this is my data file AR paper. I click on it. I click on OK. The moment I do this, I come to list variables in the data set. If you look at my cursor, it shows list variables in the data set. So this gives me a list of all the variables available. So I have PU1, which I drag it in this box, PU2, PU3, PU4. Similarly, I have PEOU1, PEOU2. This is nothing but the perceived ease of use, which is measured by three items. And then I can come down and measure my behavioral intention. BI1, BI2, BI3. Now, if you notice here, I have additional items. So I click on the delete erase objects button here. You can delete the items and the error terms. Now I want to name all these error terms. So there is a shortcut available in the plugins. Go to plugins and click on name unobserved variables. So all the error terms or the measurement errors are denoted by a smaller circle and are named by the suffix E1, E2, E3, E4. I hope you're with me. Also, if I want to show covariance between the constructs, I can click on double-headed arrows between them. So here I am trying to depict relationship between. Now, if it looks slightly untidy, there is a touch-up option. So you click on this, and it gives you a neat diagram. So this is how you can use the Amos graphic option to draw a construct. You can add items. You can have your error terms. You can so you need to open the data file, list the items, and add them into the items. Other features in the graphical interface includes running this particular program. To run this, there is something called as calculate estimates. And before calculating the estimates, you need to tell the software what are the things that you want to calculate. So you can use a maximum likelihood model. And in the output, you would like to have the minimization history, the standardized estimates, and the squared multiple correlations and modification indices. Now, what are these? I'll briefly explain. Standardized estimates are your regression path between the items and the construct. So it will tell you what are the estimates, and the squared multiple correlations will tell you the R square score. So I hope you have uh, understood how to use the Amos graphical interface. In our next session, we will understand what is a measurement model, or in simple words, what is a confirmatory factor analysis. Thank you.